my student. It's me again, Madam Gracious Kanzieni from Educare Tanzania. Welcome my Form 3 student. We are proceeding with our chemistry session series, and my student, we are proceeding with our amazing topic, which is ionic theory and electrolysis. And my student, in the previous series of our sessions, we have tried to pass through the first concept of our topic, which is all about ionic theory. Ionic theories. But also, we tried to look on the concept of electrolysis, and also we tried to look on the concept of laws of electrolysis, whereby we ended in the first law of electrolysis, whereby the Faraday's first law of electrolysis tulikuja kuprove tukaona kwamba there is a relationship between the mass liberated or consumed of the substance with the quantity of electricity produced. And tukaona kwamba katika hii first law of electrolysis, the mass is directly proportional to the quantity of electricity produced. So we ended there where we say that M is directly proportional to IT, whereby IT means that the quantity of electricity current, whereby the current flowing with the year time. So that's why there is I and T. But also that proportionality tuliona kwamba tunai-remove kwa symbol Z. Na ile symbol Z tulisema kwamba ni electrochemical equivalent. Now my student, we are going to look detailed more concerning about electrochemical equivalent, how it is used in different calculations, and also what does it mean when we talk about electrochemical equivalent. Welcome to start our session. Now, electrochemical equivalent, which is denoted by ECE, is the mass of a substance produced or consumed when 1 coulomb of electricity is passed through the electrochemical reactions. Kwamba kumbe the way that electric current in a pass through the electrochemical reactions, the 1 coulombs ambayo ile quantity inakuwa katika 1 coulombs, kwamba kumbe ndo hii mass inakuwa consumed or liberated, ndo tunaita electrochemical equivalent. Now, it has the unit of 1 gram per coulombs. What does it mean? Mean that ni mass chini ya coulombs, ambapo tukiweka hii inversely ya coulombs ndo tunakuja kupata gram per coulombs. Now, so the electrochemical equivalent ni ile mass ya substance, a particular substance ambayo inakuwa consumed or liberated in 1 coulombs of the electric current passes in the electrochemical reaction. Ambazo electrochemical reaction tunazozungumzia hapa inatokea katika electrolytic cell, ambapo tunakuwa na electrolyte or molten solution ambapo current itapass through. Vile vile tunakuwa na 2 cathodes, 2 plates or electrodes ambayo ni cathode plate or cathode electrode as well as anode electrode. Now my student, from the formula electrochemical equivalent, which is also ECE, is the slope of the graph of the mass deposited, ambayo mass inakuwa katika gram, against the quantity of electricity which are in coulombs. Kwamba kumbe electrochemical equivalent inaweza ikawa ni slope ya graph, ambayo ile graph inakuwa katika mass against the quantity, na mass inakuwa katika gram, lakini the quantity of electricity inakuwa katika coulombs. Using the data from electrode deposition of copper. Now, let us use the data of the deposition of copper electrode, whereby the slope of the graph of figure below is determined as follow. Kwamba sasa kulingana na hizi data za electrode, electrode of copper, deposition of copper electrode, from this data where it show the currents, umeme wenyewe, which is denoted by ampere, SI unit, but also we have time, how time that electric tend to be produced, ule umeme umechukua muda gani, those electric current quantity, how long it take, ndo tuna consider issue of time. But also the quantity of electricity, quantity yenyewe iliyokuwa produced au consumed. Now there is change in mass, those mass of those substance or particular electrodes. Now from here we can find a slope ambayo inakuwa ni sawasawa na electrochemical equivalent. From the slope of the graph is equal to change in mass over change in quantity of electricity. When we talk about a change in mass, mean that we are going to consider the higher mass minus the lower mass is where we are going to get the actual mass. The same apply when we talk about the change in quantity. We are going to take the large amount of quantity minus the low, small amount of electric quantity. There we are going to get the exact value of our quantity electricity. Kwa hiyo kutoka kwenye this our data here, so is where we consider the large mass and large quantity, ambapo hapa tuna 250, you can take even this one 320, it depend. Kama unachukua huyu, angalia mdogo wake, ukichukua ukitoa unapata the exact value. The same katika change in mass, unachukua mass kubwa, kuna hii hapa 0.17, unachukua na ndogo, unapata exact value of mass. Now from this demonstration here tumechukua mass 0.173 kutoa kwa masi ndogo ambayo ni 0.074 gram. So na quantity of electricity tumechukua ni 550 ambayo ni large one kutoa mdogo ambayo ni 235. Therefore finally we are going to get the answer which is 3.14 times 10 power negative 4. Lakini remember that the SI unit kizio cha electrochemical equivalent ni sawa sana gram per coulombs. Now here is where we write G per coulombs. Now my student, from there we see that is the deposition. We consider the deposition of copper, but you can see that the actual electrochemical equivalent of copper is known. It is constant, which is 3.29 power 4 exponent negative power 10 exponent negative 4 gram per coulombs. Lakini utashanga kwenye calculation tumepata 3.14 times 10 power negative 4 gram per coulombs. So why there is a difference? Simply kwa sababu this is the actual value, but you can see that one is experimental. It is from experimental data. So there is the errors. Maybe error during reading the instrument, wakati wa kunotice the number, wakati wa collect data, there is some errors made there. So because it is experimental, ndo maana obvious tumekuja kupata this value. Ndo maana tumekuja kupata this value 3.14 times 10 power negative 4. But the actual value is known in 3.29. So you can see there is just a small difference katika 3.14 na 3.9, lakini zote ni power 10 times negative 4. So why simply the value of obtained in the calculation is a bit different from the actual value because of experimental error. As I said, kama nilivyosema kwamba kumbe hizi values zinatofautiana kidogo kwa sababu ya hiyo kwamba ile tulitumia conducted data ambazo zilikuwa tabulated kwenye table, calculated like so. Lakini hii ni actual value ambayo ni known ya electrochemical equivalent ya deposition of copper. The electrochemical equivalent of some elements are given in the table below. Kwamba some of electrochemical equivalent of some elements or compounds zenye ni hizi hapa. So you can see we have substance of hydrogen, silver, oxygen, copper, gold, chromium and iron. So this is some of elements or substance ambazo zinaweza zikatumika as electrolytes katika during electrolysis. So hizi hapa ndo electrochemical equivalent zake. Sometime katika wakati unafanya mitihani yako uko umekutana na hizi it is easy for you to master them, and sometime uko kwenye mitihani yako unakuwa provided, you are provided with this data, unakuwa unapewa hizi data kwamba okay, electrochemical equivalent ya copper ni 3.29 times 10 power negative 4 gram per coulombs, unakuwa unapewa tayari. So don't get confused my students. So these are some of them. Wakati unafanya trial, unafanya exercising, utakuwa unafanya maybe unatafuta electrochemical equivalent ya certain substance, for instance copper or for instance silver, utakuja kuona kwamba okay, finally utakuja kupata hii data. Na kama itakuwa imetofautiana kidogo, itatokana na experimental errors ambazo zimetokea wakati una measure data zako. Now let us see the example. How long should a current of 5 ampere be passed through a solution of silver chloride in order to deposit 3.24 kg of silver at the cathode. Kwamba ni kiwango gani, I mean how long, ni muda gani. Here we're going to find the time. How long? How long should current, hapo umepewa na current pia. Ni muda gani huu umeme utakuwa passed, utapita kwenye solution ya silver chloride. Our electrolyte here is silver chloride. Kwa hiyo ni muda gani umeme wa current ambao umepewa hapa ni 5 utapita na ili kudeposit, kuweza kufanya deposition ya 3.24 kg of silver katika cathode electrode. Now my student, the electrochemical equivalent of silver you are given here. You see, so sometime wakati unasolve ya maswali unakuwa unapewa the electrochemical equivalent. Wakati mwingine utaulizwa utafute, so ukitafuta itakuwa ni vizuri kufanya reference. Una refer kwamba okay, is it true with the actual value or not. Kwa hiyo umepewa electrochemical equivalent ya silver ni 1.118 times 10 power negative 3 gram per coulomb as usual. Now how we can attempt this question? Now it is simply from this is our solution. We are given the mass, which is 3.24 kg. But I want to remind you, we have to consider the unit. Lazima tuzingatie vizio. Hasa tunajua kwamba tunatumia kizio cha gram na umepewa kilogram. So you have to convert your data into gram. So na ampere, I mean current ambayo inakuwa denoted by I ni sawasawa na 5. Tumepewa current ni 5 ampere. Z, which is electrochemical equivalent of silver, tumepewa ni 1.118 times 10 power negative 3 gram per coulombs. Now we know that from our first law of Faraday's electrolysis tuliona kwamba the mass ni direct proportional na quantity of electric current, lakini tukaona kwamba okay, kwenye quantity pale tuna consider the current passed through with their time. Now it means that mass is equal to ZIT. Na Z tuliona kwamba ni ile symbol ambayo ni electrochemical equivalent. So you will see, tunayo data yetu electrochemical equivalent, tunayo current ambayo ni ampere, tunayo time which is in term of second. Now you are required to find the time, how long that current will pass through the electrolyte of silver, silver electrode. So time tutasubstitute value zetu hapa. Hii mass tunaiconvert, tunajua 1 gram is equal to 1 kilogram is equal to 100 gram. So tutakuja kumultiply na 1000 ili tupate gram data. Data yetu iwe katika gram ili vizio vifanane. And here we have our equivalent, electrochemical equivalent, we have our ampere. So finally you are going to have the 5.8 times 10 power power 5 second, kwa sababu tunatafuta time. The time, essence of time is made up of second. So hata kwenye maswali mengine maybe umepewa time, you are given a certain time, lakini umepewa katika minute, katika minute. So you have to convert those minutes into second. Make sure unaangalia, consider unit. Now my student, let us look on the laws of, the Faraday's constant. Tumeona the first law of Faraday's first law of electrolysis. Tukaona the concept of electrochemical equivalent. Sasa hivi tuone the concept of Faraday's constant. The amount of electric charge carried by 1 mole of electron is known as Faraday's constant. Kumbe hii ni amount of electric charge. Amount of electric charge ambayo inakuwa carried by 1 mole of electrons is known as Faraday constant. Kwa hiyo tunaangalia ile electric charge, the charge of the compound. The charge of 1 electron is 1.602 times 10 power -9. Kumbe 1 charge of electrons sawa na 1.60 times 10 power 19 coulombs. My student, tumia hizi data kuzimaster sasa hivi kwa sababu tutakuja kuzitumia mbele kwenye maswali, simple calculations. Kwa sababu umesha master hizi data hizi, ni rahisi kwako kusolve maswali na yanakuwa mepesi. And 1 mole of electrons contain the Avogadro's number. Kwamba tunajua 1 mole of the electrons ina contain Avogadro's number. Hii tunajua kabisa, hii idea tunajua since form 1 level. My form 3 students, I hope you understand this concept of Avogadro's number of a particle ambayo ni equal to 60.022 times 10 power 23 electrons. So therefore 1 mole of electron is equal to this one times this one. Kumbe tukiwa na 1 mole of electron sawa sana kuchukua hii 1 mole of charge, I mean the number of charge ambayo sawa sana 1 mole of electrons ambayo sawa sana 1.602 times 10 power -19 coulombs mara Avogadro's number ambayo ni 6.022 times 10 power 23. So finally we are going to have the answer which is equal to coulombs per mole ambayo itaenda kuwa ni 96.47.244 coulombs per mole. The charge of 1 mole of electrons is usually approximated to this one. Kwamba hii charge sasa ikawa approximated to 96,500 coulombs. Kwa hiyo 1 charge ions, 1 electron sawa sana this one charge this one coulombs. Kwamba ukiwa na 1 mole of electrons ni sawa sawa na kuwa na hizi hapa coulombs, kwamba 96,500 C. This is the Faraday's constant, na hiyo ndo tunaita Faraday's constant. Kwa hiyo tukikutana na some calculations tunajua kwamba Faraday's inakuwa indicated by letter F. Tunajua kwamba F ni constant ambayo ni 96,500 coulombs. It is possible to determine the Faraday's constant from the given result. Yeah, ni very easy to determine their values. 1 mole of copper is equivalent to this 1 gram. Kwamba tukiwa na 1 mole of copper ni sawa sawa na 63.5 gram of copper. So and the equivalent electrochemical equivalent of copper tunajua kwamba ni 3.29 times 10 power -4 gram per coulombs. Therefore the quantity of electricity required to deposit 1 mole of copper at 63.5 is given like this. Kwamba ni sawa sana kuchukua hii mass over hii quantity ambayo tunaenda kupata this one 19,309.12 coulombs per mole. So the equation for the deposition of copper, from the equation deposition of copper hapa itakuwa reduced to copper metal. Kwamba copper ion which is copper 2 inakuwa reduced to copper metal which is, as you see here, this is copper solid, copper metal. But now because there is 2 number of that charged electrons is 2. Now this means that 2 moles of electrons are needed to deposit 1 mole of copper which is 63.5 gram of copper atom. Kwamba kumbe tuna 2 electrons, mean that 1 mole itakuwa, I mean 2 moles itakuwa required ku deposit 1 mole of copper ambayo inakuwa katika given mass ambayo ni 63.5 gram. Now the quantity of electricity carried by the 2 moles of electrons is this one kama tulivyoiona hapa. Therefore 1 mole of electrons carries, tunakuja kuequate hapa kwenye nani yetu, kwenye formula yetu. Kama kumbe tumeona quantity ni hii hapa, so at 2 moles inakuwa sasa na 1 mole of deposit copper ngapi, ndio tunagawanya kwa hii mbili charge zake, then tunakuja kupata value which is 96.504.6 coulombs. My student, your time you can use it, you can spend it to pass through wakati unafanya rehearsal trials kusolve haya maswali au kupass through these ideas ili urahisi kwako kusolve maswali, na utatumia scientific programmable calculator au normal calculator kuingiza hizi data au kusolve pembeni ili kuprove these answers. Now my student, let us see the Faraday's constant as a unit. of measurement, kwamba hii Faraday's constant kama kizio katika measurement. Now the Faraday's constant ambayo tumesema ni sawa na 96,500 coulombs is also used as a unit of measurement called Faraday, kwamba kumbe kwenye the way inavyotumika kwenye kama unit of measurement inatumika kama Faraday. Now it is abbreviated by the letter F, as I said, kwamba inawakilishwa na letter F. Kwa hiyo ukikutana na letter F unajua kabisa this is Faraday, na unajua kabisa 1 Faraday ni sawa na coulombs ngapi. That's why here it is used as the unit of measurement. Therefore 1 Faraday is the quantity of electricity charge carried by 1 mole of electrons. Kumbe 1 Faraday ni sawa na kiwango cha electric current ambacho kinakuwa carried katika 1 mole of electrons. Kumbe 1 Faraday is equal to 1 mole is equal to 1 Faraday is equal to 1 is equal to 1 number of electrons and so forth. Generally, we can simplify this by like this. The amount of mole of atom of element liberated or deposited at the electrode is equal to kwamba kile kiwango cha the amount of mole of atom, kile kiwango cha mole of atom ambacho kinakuwa liberated or deposited katika electrode kinakuwa sawa na number of mole of electrons passed, kwamba zile number of electrons ambazo zimekuwa passed chini ya ganya kwa number of charge on each ion. Kwa hiyo tunachukua number of mole ambayo imekuwa passed, number of mole lakini zinakuwa number of mole of electrons ambazo zinakuwa passed in the electrolyte, lakini tuna divide by the valence, their valences or charge of each ions. Tunaangalia zile charge, na kwenye charge zile tunaangalia zile ions, lakini haina nini, tunavyo consider valence mean that no charge. Hatuweki zile kama ni positive ni negative, we are just taking them as a whole number. Kama ni valence ya 2 sisi tunachukua 2, kama ni valence ya 3 tunachukua 3 and so forth. Now 1 Faraday discharge 1 mole of the silver ions or 1 mole of sodium ions, kwamba 1 Faraday yenyewe ita discharge the 1 mole of silver or the 1 mole of sodium. For instance, you can see here this is the ions of silver. Now it is reduced to silver metal, as you can see here, the silver sodium. Also we have the sodium ions ambayo inakuwa reduced to sodium metal. Kumbe 1 Faraday ni sawa na 1 mole of silver ion kama unavyoona hapa. Kumbe 1 Faraday itakuwa sawa na 1 mole of silver ion. The same apply to the 1 mole ni sawa na 1 moles or 1 Faraday ni sawa na 1 moles of sodium ions, the same. Vile vile tukiwa na 2 Faraday zita require au zita discharge required to discharge 1 mole of magnesium ions or calcium ions. Vile vile 3 Faradays and are needed to discharge the 1 mole of aluminum ion. Kumbe tukiwa na 1 mole of Faraday ita discharge 1 mole of sodium or silver, lakini tukiwa na 2 Faradays ita required ku discharge the 1 mole of magnesium ambayo ni hiki tunachokiona. Kwa mfano hapa kama nitakuwa na 1 Faraday, it means that the 1 mole of this silver mean that kama nina 1 mole of silver mean that 1 mole of Faraday itakuwa required to discharge hii hapa ion of sodium. Ndio kinachotokea hapa. Let's see the very simple example here. A current of 3.2 ampere is passed through the solution of copper to sulfate for 30 minutes. Kwamba kiwango cha umeme ambacho ni 3.2 ampere kimepita katika solution ambayo solution yetu au electrolyte yetu ilikuwa ni copper 2 sulfate. Lakini kwa muda gani? Dakika 80. Dakika 30. 30 minutes. What is the mass of copper deposited at the cathode? Ni masi kiwango gani au ni kiasi gani cha masi ambacho kimekuwa deposited katika cathode electrode? Here we have the copper, the molar mass of copper is this one. We have the S, which is for sulfur we have 32. Hizi ni molar masses. 32, oxygen is equal to 16. I hope my students you are aware about this concept of molar masses. That is element. Now our solution is very simple. Kwamba our data we have current, we have time. lakini time tumepewa katika minute, we have to convert into second. So we know that the quantity is equal to IT. So we are going to substitute our value ambazo tunazo ampere time time, lakini time inatoka kwenye second, kwa tunazidisha na sekunde 60, kwamba 1 minute is equal to 16 seconds. So nikiwa na 30 minutes sasa na sekunde ngapi? It means nitachukua 30 mara 60 kupata sekunde. Kumbe the quantity ambayo itakuwa liberated ni hii hapa 5760 coulombs. Now the number of mole of electrons itakuwa sawa na this one over Faraday's constant, kwa sababu tunajua kwamba kiwango ambacho kitakuwa liberated or deposited ni sawa na ile number of Faraday's. Ili kupata the number of mole of electrons, sasa tunachukua this quantity divided by Faraday's quantity or Faraday's number, whereby we are going to have the 0.0597 moles, and it will be moles because here ipo per mole. Coulombs and coulombs zinaisha. Do you see, my student, the way the SI unit are the way you are required to consider the SI unit? Kwa sababu hapa tuna coulombs zitaisha, itabaki hii per mole. Hii per mole it will go here, itaenda juu. Ikienda juu mean that inaisha, inakuja kurudi kawaida. Kwa hiyo tunakuja kuwa na our mole here, number of mole of electrons ambazo zinakuwa discharged here. So since the copper ion ambayo ni copper, which is copper 2, has 2 charges, kwamba yenyewe ina 2 charge. Now the number of mole of copper discharged is given by, kwamba sasa tukiangalia ile number ya copper ambayo imekuwa discharged itakuwa sasa na ngapi? We know that we take that number of mole of electrons divided their valences. Kumbe copper yetu ni copper 2, valence yetu ni 2. So we are going to we have this is number of mole of our electrons over 2, which is the valences ambayo tumeikuti kwenye equation yetu hapa. Finally and obvious, we are going to have 0.0298 moles. So my students, you will use your calculator so as you can prove this during your trials. The mass of copper is this one, kwamba mass of copper tumepata ni hii hapa, moles of the mass of copper in this one, moles of copper ni sawa na kuchukua number of mole times molar mass. We know that N is equal to mass over molar mass, kwamba number of mole sasa na mass of a substance over molar mass of a substance. Sasa tunatafuta mass ya copper deposited, lakini molar mass ya copper tunayo. Number of mole of copper tumeshaipata. So what's happening, we are going to take the mass of copper katika hii hapa moles ni sasa na kuchukua number of mole times the molar mass, ambapo but molar mass of copper tunajua kwamba ni 63.5 gram. Mass of copper deposited tushaipata, ambayo itakuwa sawa na moles tulizozipata 0.0298 moles times the molar mass ambayo ni gram per mole 63.5. Finally we are going to have